This is a demonstration of a new feature that is going to be in the next release of LiveRecorder for Java. And what we're going to demonstrate here is a way to analyze out-of-memory errors. So we can take a HProf dump that's produced by an out-of-memory condition, and we can analyze it with a memory analyzer and then get the address of an object. And what we can do is, if that out-of-memory condition has been recorded using LiveRecorder, then we can go back in time to find out where that object was created, despite the fact that that object might have been moved around by GC multiple times. So let's take a look at some sample code. So this is a very simple little demo. It's just a Apache server. It's a spell check program, and all it's doing is taking a sentence that's provided and comparing it with a set of words to make sure that it's spelled correctly. And this word set is loaded per session as an attribute and saved for performance. It's cached, and we'll see what happens. So I've got it running here, so we can enter a sentence. And you can see it's wordless added session, and it's told us it's incorrect. Do it again, and then that's okay. So what we'll do now is we'll do some stress testing. So we'll basically force an out-of-memory issue. So I've got a stress script here that's just going to repeatedly call the API. And at some point, it'll go slower and slower as it's using up more and more memory. And then we'll get an out-of-memory condition. See, empty reply from server. So let's stop that. And if we have a look at the log, then we can see that we have indeed got an out-of-memory condition. And the way I've got it set up, I get a HProf file output because I've got the option here to output a heap dump. And we're also going to, when the server is shut down, we also get a spellcheck.undo file, which is a recording. So this is actually being recorded at the moment. But I've got a recording that I made earlier, which is the one that we're going to look at now. So let's take a look at the recording I've already made and replay this session. So this is just, if you're familiar with LiveRecorder, so this is just replaying replay a recording that I made some time ago. Let's shut down the server because that's using the same port. Okay, so let's replay that recording. So what I've got set here is I've put let's view breakpoints. I put a breakpoint on out-of-memory error. So we need to go to where the out-of-memory thing was thrown before we track back. So what we're going to do is we'll go to where the out-of-memory error was thrown, and then we're going to track backwards and locate where a particular object was first created. So let's replay the recording. So it's connected, and it's going to it's replaying it, and this is the normal output from Apache. And let me show you Eclipse Memory Analyzer in a sec, once this has done what it's doing. Okay, so that's the point where the outer memory has been thrown. Let's go over to Memory Analyzer. So I've got the HPROF file that goes with the same recording. And if we look at so we can see a great big chunk of it has all been taken up by this Catalina session thing. If we look at the dominator tree and just start drilling down in the dominator tree, and we'll see attributes. So there's a typical large let's just go one step further. There's a typical large hash set there, which is 9 megabytes big. But you can imagine in a real life scenario, this is quite a trivial example just for this demo. In a real life scenario, you might not know how that got there, what populated it, how it came to be that this hash map has got all these entries in. So you want to go back and figure out, where did that come from? How did it get there? So let's click on that, and so we've got the address of the object here. So let's take the address, let's copy the address. So now what we're going to do is, there's another thing we can do. Let me show you another thing we can do. So this is going to be using UDB, which is our command line interface. So we can load the same recording in UDB. We can go to the end of the recording, which in this case is pretty much after the outer memory has been thrown. And we can check that address and verify that it is an instance of hash set as expected. So going back to here, so we're currently at the outer memory. So what we're going to do now is go backwards in time. So we're going to go backwards in time to find out where that object was created. So we've got our log jump panel here, which we can do various things with. We can go to a timestamp, UTC timestamp. We can go to a BB count, which is a kind of measure of how far through the recording we are. Basic block count. Trace ID is to do with when we're using microservices and we want to step to a particular trace ID from a telemetry, and object ID, which is the address of an object. So let's put in the address of that object, press OK. So now it's going back in time. So just to see what's going on, we can go to the output from our replay session here, and we can see the object being moved by GC. And just to show you a quick diagram of what exactly is happening here. We've got our object created here, and then garbage collector is basically moving this object around. It's moving it from there to there to there, and there we go. So it's done it. So there it is. It's gone backwards in time to the point where the object was created. And from there, you can do your normal step over, we've got the normal step back, step over, etc., etc., etc. So, and and that's it. Oh yeah, the other thing I wanted to show you was you can do you can also analyze it in UDB if you want to. So you can see the object being traced here as it's moved by GC from place to place. And the way this works, by the way, is by setting reverse watch points on the class pointer. So this is down here in the bottom right hand corner. We've got the location where it finally ended up at the outer memory thing. And but at some point, this class pointer gets written to. So we can set. So what we're doing effectively in all this is setting a reverse watch point on that class pointer and going back to where that was populated by copying the object from here, and then similarly setting a watch point on that class pointer to find out where this came from, and this back to where the object was first created. And like I say, if you want to, you can take that same BB count. You can go to that in UDB, which is effectively the same as GDB, but just with reverse operations. So Yugo time is going to that BB count, and we've got a command JBT Java backtrace, which is something that we've added to. It's a Python unwinder that we've added, and that'll give you the same stat trace. So yeah, quite powerful potentially. So, and that will be in the next release out in early January, hopefully. Okay, that's all for now. Thanks. Bye.